Okay, so this is just a short video with a couple of examples of hyperbolas centered at the origin. Okay, so from the equation, we could look at this equation here and notice a couple of things. First of all, x squared is positive. Okay, so that means that we have a horizontal transverse axis. And just a reminder that the transverse axis is where the vertices are. So our vertices are going to be horizontal along the x-axis in this case because our center is at the origin. Okay, we know our center is at the origin by looking at the equation because there's nothing being added or subtracted from the x squared and y squared. So while the center is not actually on the graph, I do like to just kind of draw it there. Okay, and when we draw a hyperbola, we start by drawing a rectangle. And that rectangle is going to have the dimensions that are going to be indicated by a and b, right? A squared is 25, which means a must be 5. So this rectangle is going to go out 5. Out 5 from either side of the center. And the 16 is indicating that we're going to go up and down 4. Okay, and then we can draw a rectangle to kind of guide where we're going to place our hyperbola. Okay, and as I mentioned that the transverse axis being horizontal means that the vertices are directly on the horizontal axis. Okay, and since we're at the center, the vertices are exactly where my rectangle is in line with the center. Okay, and we have asymptotes in a hyperbola, and the asymptotes are kind of dictated by the diagonals of the rectangle that we drew. And when we draw the actual hyperbola, we draw it so that it approaches the asymptotes on either side, and with its vertex at the center of each branch. Probably should have drawn the hyperbola in a different color so that you could see it a little bit better. But so personally, I think it's easier to draw the hyperbola and then kind of indicate all of the analysis. So the vertices are at plus or minus 5, 0. That's two separate points, right? 5, 0 and negative 5, 0. The foci we'll get to in a minute. The asymptotes here, this is simply just the equation of a line. Okay, and we can see that rise over run. Our slope here is up 4 over 5. So we have an asymptote at 4/5 x. There's no y-intercept, or the y-intercept is 0, so just 4/5 x. And then we also have our other asymptote here. We go down 4 over 5. Right, so that slope is just negative 4/5, so y equals negative 4/5 x. You could write that all in one if you want. If you want to write just plus or minus 4/5 x, that's fine. Okay, so when the center is at the origin, the asymptotes are always going to go through the origin, so there is no y-intercept in our equation because it is 0. And that's always going to be the case. It doesn't matter whether we're centered at the origin or not. When we're writing the equation of these asymptotes, we can always use a corner of our rectangle and the center, wherever the center might be. And then you could use point slope form if that's easier, or slope intercept form if it's easy to see where the intercept is. But we'll get that's in a separate video. I'll do translations of hyperbola. Okay, and then the foci are the last thing. The foci, we're going to use our formula, our c squared equals a squared plus b squared formula, okay, to find the foci, keeping in mind that c is the distance from the center to a focus. Okay, so c squared equals a squared plus b squared, so that's c squared equals 41. So c is the square root of 41. Okay, so that puts our foci, the square root of 41 is between 6 and 7, so it's like one focus there, one focus there. So our foci are plus or minus square root of 41, comma 0. Okay, we can't simplify that at all. So we have foci, we have asymptotes, we have vertices. Okay, so this is an example of a horizontal transverse axis. The next one that I have here for you has a vertical transverse axis. Again, we could tell that by looking at the fact that y squared is positive. So we'll draw our rectangle again. I'm actually going to do it in a different color so that we could see the rectangle a little bit better. We can see that our rectangle is going to go from our center at the origin up 7 and down 7, right? That 49 gives us the 7, and across left and right 3. Right, so we have this rectangle here, and draw the diagonals for the asymptotes. Okay, and again, so this is a vertical transverse axis, which means that the vertices of my hyperbola are on the vertical axis. Right, I'll do that in black. So I have one vertex here, the center of my rectangle, one vertex down here, and we draw our curves. Right, so our vertices are 0, plus or minus 7. The asymptotes here, again, we have a center at 0, 0, so a y-intercept of 0, so we really just need the slope, and the slope we can see is just you know, the like half the height and half the width of our rectangle, up 7 over 3. So our asymptotes are plus or minus 7/3 x. And the foci, we'll do that c squared equals a squared plus b squared again. So c squared is equal to 57, which makes c plus or minus the square root of 57. Okay, and again, our foci are, so plus or minus the square root of 57 is somewhere between 7 and 8, so they're like here and here. It's hard to draw because I'm running out of room. But they're on the y-axis, so 0, comma, plus or minus square root of 57. Okay. All right, so these two examples, I'm just going to do one of them because they're pretty similar. The only difference between these examples and the ones we just did is the fact that we have to first write the equation so that we can set it equal to 1. So we'll do the top one. Right, we're going to divide everything by 36 and rewrite this so that we end up with y squared over 4 minus x squared over 9 equals 1. Okay, and just a little hint, if you ever, you're really just simplifying a fraction here, right? So 9, this is 9/36, simplifies to 1/4. 4/36 simplifies to 1/9. If you ever end up with a coefficient up here, you probably did something wrong, because even though you can, there are hyperbolae that exist that are like that, it's a lot more complicated than it's worth for our purposes. So you shouldn't see any coefficients of x squared or y squared when you do the division, or when we get to it, do the completing the square when the center is not at the origin. Okay, again, we're centered at the origin, and we're going to draw our rectangle. We have a positive y squared, right? So we know that our vertices are going to be on that vertical axis. All right, this time we're only going up and down 2, since our value underneath the y squared is 4, and we're going left and right 3. Right, so we'll draw that rectangle. And our asymptotes. And it's a positive y squared, so our transverse axis is the vertical axis. Our vertices are at 0, comma, plus or minus 2. And we could just draw our hyperbola. Our asymptotes, looks like we rise 2 and run 3, so we've got asymptotes at plus or minus 2/3 x. Again, we're still centered at the origin, so we do not need a y-intercept. And then our foci, we're going to use that c squared equals a squared plus b squared. So that's 4 plus 9. So c is plus or minus square root of 13. So we have foci at 0, comma, plus or minus square root of 13. Okay, so let's take a look at a couple examples where we're working backwards. Okay, so the consensus in class was that it was pretty easy for students to look at a graph and work backwards, but it was a little bit more difficult when you were just given information to work backwards. And I just selected a couple of the examples instead of doing them all. They're all pretty similar. So my suggestion would be is, we'll start with this one. So if it's easy to write from a graph, then my suggestion would be draw a graph of the information you have if you're not given a graph. So let's just start with a graph so that because, like I said, but the consensus was that it was the easiest. All right, so the information, we know a couple of things about this. We know that y squared must be positive, right, because we're looking at a vertical hyperbola here. So I would start just by going y squared minus x squared equals 1. And now we just have to figure out what what's in the denominator of these fractions, and keep in mind that whatever goes below y squared is telling us something about this rectangle, right? The distance from the center to the vertex is the square root of whatever goes under this y squared, and the distance from the center to the edge of my rectangle is the square root of whatever goes under this rectangle. Okay, so it looks like we have a distance of 5, so that must mean under y squared is 25. And it looks like we have a horizontal distance of 3. So under my x squared must be 9. Okay, so it is fairly easy to do from a graph because you have, as long as you have an understanding of where the parts of the graph come from. If we go back here, a little more challenging, but you kind of have to use what you know. And again, my suggestion would be to graph the information, right? So we're being told that we have vertices at -5 and 5. Okay, so that means we have a horizontal hyperbola, sorry. And then we have foci at 7 and -7. Okay, so I did foci in red, I did vertices in black. Okay. So we have enough information to know that x squared must be positive. Right? We know we're centered at the origin because we haven't done any examples that aren't centered at the origin yet. But the other reason we know that is that the center is going to be right in between my vertices, right? And since my vertices are at -5 and 5, the center at the origin is right in between. Okay, so we know that. We know that what goes under x squared has to be the distance from the center to a vertex, right? Or the square of the distance from the center to a vertex. Okay, so under x squared must be 25 here. All right, but how are we going to figure out that y squared? Okay, so keep in mind y squared is really just whatever this, if we had this rectangle here, we don't have it. Okay, but if we had this rectangle here, what goes under the y squared is really just the square of whatever this distance is. But we can't figure that out. We can't just guess. Okay, so these foci must come into play here. Okay, keep in mind we have this formula, c squared equals a squared plus b squared. And in this case, we know what a squared is, right? That's 25. We figured that out already. We could also figure out what c squared is because c is the distance from the center to a focus. So c squared must be 49. Right, so 49 equals 25 plus b squared. So that means that b squared must be 24. And we don't really care what b is because we need to put b squared under my y squared, so it's 24. Okay. Okay, so let's look at another example. It's a little more complicated. Okay, because the information that's given, it looks like a little less information is given, let's say. All right, so we're told that the endpoints of our transverse axis are 0, -6, and 0, 6. Okay, so that tells us that our transverse axis is positive, right? We're going to have a hyperbola that looks something like this. Okay, so our transverse axis is vertical, rather. So we know we're going to have a positive y squared. Okay, we also know that, oh, I'm sorry, what I didn't mention was that if the endpoints of the transverse axis are 0, -6, and 0, 6, that must mean that our vertices are 6 and -6, right? Because the endpoints, the transverse axis is where the vertices are, and the endpoints would just kind of indicate to us where that rectangle goes. Okay, so the other bit of information we have is that we have an asymptote at y equals 2x. Okay, so let's see. 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3. So that means we went up 2 over 1, up 2 over 1, up 2 over 1. Right? So this is the point 3, 6, right? Because it's got to satisfy this equation over here, y equals 2x, right? So that must be the point 3, 6, the corner of that rectangle. Okay, so that means I could finish drawing my rectangle. And that this distance here, the one that I need for underneath my x squared, is going to be 3. So 3 squared is 9. And I forgot to put under my y squared that we have a 36 here. Okay, so just to review that one more time. I used the asymptote to figure out where the corner of my rectangle is, what point is on the corner of my rectangle, right? So the asymptote is the line y equals 2x. That's one asymptote. The other one must be -2x, right? But it doesn't really matter. Y equals 2x. So y equals 2x means if I start at the origin, I went up 2 over 1. That's the point 1, 2. If I keep going up 2 over 1, that's the point 24. Up 2 over 1 is the point 3, 6. Right? So this 3, 6 must be the corner of my rectangle. And if I follow it down, right, that means that my rectangle, the horizontal distance from the center is 3. And that's what's going to go under my x squared. The 36 comes from where the vertices are. And that's it for hyperbolas with centers at the origin. I will do a separate video with translated hyperbolas.